Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Earth Losing Atmosphere Due to Planet X Related Gravitational Diffraction. Now, as I have detailed in previous articles, gravity is a wave, which is not surprising as the gravitational interaction arises from photons or light, which is also a wave. The fact that gravity is a wave causes gravitational diffraction effects to appear whenever massive objects closely approach each other. The gravitational diffraction effects are observed as gravitational vortices. That small stellar cores closely approaching the surface of the Earth create gravitational vortices, such as waterspouts in the Earth's atmosphere. You can see a waterspout here, a gravitational vortex over water, which draws water upwards. You can actually see the water flowing upwards along the vortex. So you can see the water spiraling upwards. Water is forced upwards by a gravitational force which pulls it upwards. Otherwise, you will never move upwards. The Earth's gravitational force would keep it on the surface of the ocean. So the source of a gravitational force is, of course, an object with mass. So the fact that we have a gravitational force pulling water upwards from the surface of the ocean means that we have an object with mass up here. Gravitational vortices can be seen to be a diffraction effect because they also arise from small holes in containers filled with material that will flow under the effect of gravity. In other words, these small holes act as gravitational sources. Just like diffraction of light occurs when light passes through small holes, and that is, they are small with respect to the wavelength of the light, so that light waves spread out from these holes, and this is what's illustrated here. When light passes through a small hole, it's small enough to be about the same size as the wavelength of the light, then the light spreads out from this hole as if the source of the light was the hole. And if the light is reflected backwards, then it's reflected in such a way that it spreads out as well. So there's diffraction on both sides. Now, so these gravitational diffraction effects are observed whenever massive objects approach each other to a distance which would be about the same size as the wavelength of the gravitational wave generated from the gravitational interaction between the two objects. And it is also observed when material under the effect of a gravitational field is allowed to flow through a small hole, such that the material is not able to free fall through the hole. The diffraction effect is in the form of a vortex, and this is illustrated here. We have water droplets. These water droplets will fall right through this sink drain, which creates a hole, without any gravitational vortex effects appearing, i.e. no gravitational diffraction, because the hole is large in comparison with the amount of material falling through it. So the interaction between the droplets of water and the Earth produces a wave which has a wavelength which is much smaller than the hole. In other words, the hole is large for the gravitational wave that's being generated here. Whilst if you have a sink full of water, now you have a large amount of material, and the gravitational force between this material and the Earth produces a gravitational wave which has a larger gravitational wavelength. So the hole is now small in comparison with the wavelength of that gravitational wave, so diffraction effects appear. And these diffraction effects are in the form of a vortex. And this vortex is always widest where the force is strongest. It's strongest at the top of the water. And the water going through the hole continues to fall as a vortex after it passes the hole, indicating that diffraction occurs on both sides of the hole, and the top and the bottom, just like it does with light. in this case, the gravitational interaction between the water in the hole, the water above the hole or in the hole, and the Earth generates a gravitational wave with a wavelength which is larger or about the same size as the hole through which the material is flowing. That's why we have diffraction effects, exactly the same as with light. As massive objects approach each other, gravitational wave will affect both, because the gravitational wave arises as a result of the interaction between the two objects. So the gravitational wave does not actually form until there is an interaction between two objects, but it is usually only observed if the objects have material which deforms easily in response to the gravitational wave. So if a completely solid object approaches another with a liquid surface, such as the Earth, the gravitational wave effects will be observed on Earth's oceans. And this is what it looks like. So a gravitational wave forms due to the interaction between the stellar core and the water on the Earth. And the gravitational wave produces this wave. It will have bulges, it will have a central minimum. There's always a central minimum. All vortices have central minimums, including this one. If you ever seen a vortex in a sink, you know there's a hole right through the middle, and that's because the gravitational wave always has a minimum in the center, a central minimum. So as the stellar core approaches, the wave height increases until it gets to the point where it's so close that the distance is less than the gravitational wavelength that forms as a result of the interaction between the stellar core and the Earth. So a small object can thus pull material from the surface of the Earth because its position is defined by its center of gravity or center of mass is closer to the surface of the Earth than the Earth's own position. If the small object has a surface which is also deformable, such as a gaseous atmosphere, this material will also exhibit gravitational wave effects. And it is less dense than water, it will be even easier to deform and will therefore make contact with the Earth's liquid layer first. And this is what's observed here. So the Earth exerts a force on the stellar core, and therefore it creates a wave effect on deformable material on its surface, whilst the stellar core exerts a force on the Earth's ocean and causes this wave pattern to appear with bulges and a central minimum on the surface of the Earth. So there is a mutual effect on each other, and a wave forms on both objects. But if the stellar core is just a solid object with nothing to deform on its surface, the only wave that will be observable will be on the Earth's surface itself. And if it's ocean, it will form this type of wave. Now, so as you can see here, the stellar core, as it approaches the Earth, the wave height will increase on both objects. And if the stellar core has material that is easier to deform than the Earth's oceans, then its wave height may increase to the point that it will make contact first. So this material will exhibit gravitational wave effects. If it is less dense than water, it will be even easier to deform and will therefore make contact with the Earth's liquid layer first. However, once contact is made, it is likely that water will flow upwards towards it. This is again because the object's center of gravity is closer to the water, so that it will exert a stronger force on it than the Earth is able to exert. You see, this is the center of the Earth. It's quite far to the surface of the ocean, whilst the stellar core, the center of the stellar core, is closer. So it will exert a stronger force on the water, on the ocean, on the surface of the ocean. It will be able to draw it upwards through this gravitational vortex. Now, gravitational waves will also most likely form in the Earth's atmosphere as stellar cores approach the Earth. And through the connections made with the atmosphere, these objects will be able to draw Earth's atmosphere and turn it into their own atmosphere. So the same will be occurring, but above our atmosphere, somewhere where we are not able to see, but the same thing will happen, except that instead of ocean, it will be Earth's gaseous atmosphere that will be drawn upwards towards these stellar cores that are outside the atmosphere or very close to it, and may even be inside it, but too far to affect or make contact with Earth's oceans. But these objects will be drawing Earth's atmosphere instead and making it into their own atmosphere. And so they will draw and take away from the Earth's atmosphere, just like they did with the sun, or the sun's atmosphere or the sun's corona, for many years, until the sun could be seen to almost have no corona left. And you may look at article 401 entitled "The Sun's Current State, Brown Dwarf or Planet." In conclusion, Planet X system stellar cores are drawing both ocean water and atmosphere from the Earth, just like they have drawn the sun's coronal and chromospheric plasma. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.